Hi, welcome to the next lecture. In this lecture, I'm going to create the process for the clock. Okay, so as you remember, I told you to create this clock for the QSPI, and we just took this clock and loop it out. Okay, now I decided to add here two things. Okay, I decided to write here this will be 100 megahertz, the input clock that we will add from the test bench. And this, for example, you can use in your system different clock, okay? But the method will be the same, okay, of what we are going to do. And this will be the clock for the QSPI out, so it will be fit into the DTR and STR. And if you don't remember what STR and DTR means, you can go to the previous lecture when I explained on the PDF. Okay. Now we will use the 25 megahertz because we are using the STR, but 25 megahertz actually fits to the DTR and the STR too. Okay. So I've told you to create this thing here. This will be fine, okay, but not so good if you're thinking about this. There might be some problems, okay? Now let's go on and think. So we have this FPGA, okay? And as you know, inside the FPGA, or as you don't know, we have the clock tree, okay? So some of pins are dedicated for clocks. So let's say that this is the dedicated pin for clock, and you put here, your 100 megahertz clock. Okay. Now, if you put here your clock, it doesn't matter what is the frequency. If you put here a clock, and it's of course, you need to put it on dedicated clock for a global clock, okay? Then the clock will be able to reach all of the areas of the FPGA, okay? In the, let's say, in the fastest time that it can, okay? So the FPGA built this way, so you will have here really fast buffers that will make the clock reliable in all of the places of the FPGA, okay? Now think about that we have here our QSPI or any other component actually, and I want here this clock, okay? Now if you just connecting here and let's say you have here the data, okay? So right here you will have the data and the clock. Let's say that I want to change the clock frequency, okay? So we want to create 100 megahertz to 25, okay? Now, if you want to use this state machine here, of course you want it to be in the same clock rate of 25, because you need to send the data and receive data and do all this stuff. So you might think that you can just take this clock and just put it into your state machine and use it, okay? But you can't, okay? You can't do this. And after using this flip-flop, this clock is not in the clock tree, okay? It's not reliable, okay? It depends on your synthesize tool, and I don't know what will happen. So for making professional design, we won't do this. So what we need to do, we need to take this 100 megahertz and we need to create something that called clock enable. Okay, so this clock enable will actually enable this clock of 100 megahertz. And what does it mean? So two things that we are going to do, okay? So let's say that we have the 100 megahertz clock. Okay, let me just create this clock. So let's say that this is the 100 megahertz. Okay, and then we want to create 25 megahertz for all the for all the processes. So 25 megahertz will be just like, let's just do it in a different way. Okay, so let's say it's 0, and then right here it's rising 1, and then go to 0. Okay, you can say it's coming from here. It was 1. Okay, so this will be the 25 megahertz. Okay, and this will be the 100 megahertz. Now, if we will use a counter to create this 25 megahertz, okay, as we are going to do, then this clock cannot be used in the internal processes. Okay, so what we want to do, first of all, with the counter and this clock, we can send it out okay, to our QSPI. It will be fine. And you will have to create constraints and everything. Okay, but it's not within this course. Okay, we will just simulate it, and the constraints needs to come to your tool that you're using. If you're using VIVADO, if you're using Quartus, okay, and or any other tool. Okay, and so for the internal processes and everything, we will need to create a clock enable. Okay, and this clock enable will just enable my clock right here. Okay, and on the next time it will enable it just right here. Okay, so what happens is that the clock enable will just be 0, and only right here it will rise up. Okay, just right here, and it will enable the clock enable. Okay, actually it's rising up right with it. Okay, and it will enable this pulse, and it will go to 0, okay, on the next lock, and then it will come up again. Okay, so what happens here, that we will use two things, one to create this 25 and the other one to create the clock enable. So this is what this lecture is about. So first thing first, let's just go on and take this process and delete it. Okay, and first thing I want to do here, I want to take this clock, which is the input clock from the pins of the FPGAs. Now I want to put it inside all of the processes, even to this process, and it will be inside every process. Okay, and what we're going to do on right next, okay, this is the read data process that we have created on the previous lecture. What we're going to do, okay, we're going to say if clock enable is 1, okay, because this process is an internal process. Okay, then do all of this. Okay, and if. Okay, now right here we want to create, let's just call it clock enable process. Okay, and let's just go on and create signal, this signal, the clock enable signal. Okay, right here we want to reset it. Let's make it start from 0. Okay, and we need actually a counter. Let's just call it CNT. The counter. and it will be a vector. Now let's just think. Okay, so let's see what happens here. Yeah. Well, I want it to be counting. Let's say that this is where it counts to something, and then it's starting counting from here. So it will be 0, 1, 2, and 3. Okay, so I need the counter from 0 to 3. Okay, this is what I need. Okay, first of all, I want to. Now we need an if here. Okay, so if the clock counter is smaller than 3, then just keep the clock counting. Okay, and the clock enable, of course, will be 0. Okay, else, sorry, what I need here, yeah, okay, else is when clock enable counter is 3. Okay, and if okay, so when it's going to 3, let's say right here it was 3. Okay, so this clock rising edge detected the 3 and just set this to 1. Okay, and set the clock to 0, and on the next rising edge it will count to 1 and we'll set this to 0, and so on and so on. Okay, so this is the clock enable process, and this is the clock enable that every 4 clocks, okay, from 0 to 3, it will rise up for 1 clock and then go back to 0. Okay, one more thing we forgot here. We need to reset the clock counter. Okay, now let's just go on and copy this one, and now we will create the clock QSPI Flash 25 megahertz. Okay, so we're using with the same clock, but we have different signals. Okay, so we have already this QSPI clock out, and we need another counter. So for this one, we need a different counter. Okay, so let's say that right here we are on 0 and 1. Okay, so with 0, 1, 0, 1, we just need a small counter. It's actually a bit, but don't get mistaken. We need to count. We needed to count to 1, and yeah. Okay, so let me just think. Yeah, okay, so let's just count. We'll have this counter. Let's just call it counter. Okay, QSPI clock CNT. Yeah, it's just an STD logic actually. Well, I need to write it in a different way. Well, yeah, okay, so if this is the divided of 2, I think I made a small mistake here. Okay, so this one will go to be 2, and let's just change this clock counter to 1 down to 0, and this right here will say just smaller than 100. Okay, because when it's going to change to 4, okay, it just will set it up to 0. Okay, right here. Okay, so I think this is how I should write it. And yeah, okay, so and right here we will just, the counter will be, you know what, let's just copy it one more time maybe. Okay, and I will change the numbers and the names, of course. So this one will be, I could use the same process, by the way, but let's not do this. Okay, I want it to be arranged, and right here I have this QSPI. Yeah, so this is the new clock counter. Okay, so we need to change this, because what happens here is that I have did this thing here, and what we want to do is actually when the clock counter, I needed this clock to be 1, okay, for 2 clock counts. So on 0, 1 it's going to be 0, and on 2 and 3 it's going to be 1, and again. Okay, so you can do it in many different ways. Let's just make it the easiest way. Okay, and what I'm going to do is just I can do it like just like this. Okay, so when it's 2 and 3, I'm going to be 1, and of course the clock counter is counting. Yeah, okay. So the clock counter will keep counting, and when it's going to a 3, it will go back to a 0. So there is nothing else to do here. And under else, we just hold all the states here. Okay. So don't you ever forget your else statement. Okay. Although there is nothing else here that can happen on else. Okay, so as you can see, it can be 0 and 2, 0, 1 and 2 and 3. Okay, so we can leave it that way. Okay, this way. Another way we can write it just like this, and we can actually we don't have to put this if we are saving it, but I will just leave it like this. Okay, so it will be easier for you to read, and this is it for this lecture. Okay, and I will see you on the next lecture. Okay, thank you.